Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4, Section 4. We can present about our project. This is about flood mitigation. This our group member, Abdul Malik Darwish, Muhammad Firdaus Syahmi, Adam Daniel, Wan Muhammad Fatih, and Zaid.
Assalamualaikum, my name is Muhammad Fatih Irsyad, number matric DF230155. The authoritative manual for stormwater drainage design in Malaysia is the Urban Stormwater Management Manual for Malaysia, commonly referred to Manual Saluran Mesra Alam or MSMA. The MSMA emphasizes environmentally friendly approaches to stormwater management, addressing issues such as flash flood, river pollution, soil erosion, and sustainable urban development. The second edition of the MSMA expands on this concept, incorporating the latest developments and addressing contemporary challenges in urban drainage. This one is the problem for this project. The part of Taman University Paik Raja area, where the area outlined in red, is prone to inundation due to flash flood, which occurred during short and intense rainfall.
Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. My name is Abdul Malik Darwish Alim. I am from Group 4. So, I will explain this part, the reason why flash flood occurs at the location. So, we will focus about 5 reasons. So, we will explain one by one. Okay, the first one, in the kite dredging system. The region's dredging system is not built to manage the amount of water that falls during periods of intense rainfall. The system's capacity is frequently exceeded, which result in water strangling and flooding neighborhoods and streets. It is functionally degenerates even more when routine maintenance is neglected. Okay, the second one, urbanization. Structures like highways, buildings, and other impermeable surface have supplemented open space and woods due to the rapid development of metropolitan areas. The insurance service runoff by this reason the ground's capacity to absorb rainfall. Furthermore, the problem is made worse by the absence of the green areas and routine zones. Okay, the third one, flat topography. Water movement is slowed by Bartraja, naturally flat topography, the metal bold up underlying places in the absence of 70 slopes or naturally drainage channels, causing flash floods during storm. Okay, the fourth one, high intensity rainfall is common in the region, especially during the monsoon season. This unexpected downpours generate a large amount of water in little amount of time. If it takes things during infrared pressure. Okay, the fifth one, close drink. Litter, salt, and other waste materials that are not properly manipulated sometimes cause closed drains. Flooding and backup result from blocked drains that make it difficult for water to leave the region efficiently. Okay, that's all for the region-wide flash flood across the location. Thank you. See you next time.
Now, I can present about purpose flood mitigation method. We have 3 points. So the first point is main cause of flooding. Poor drainage management due to overground vegetation, waste build-up, and inadequate maintenance reduce water flow and drainage capacity, making the region prone to flash flood. The next point is about flood mitigation strategy. So the first point is vegetation clearance, remove plants, tall grass, and debris to ensure unimpeded water flow. The second point is regular maintenance, implement systematic cleaning to prevent blockage. The third point is structure upgrade. In the structure upgrade, we have 2 points. The first point is concrete linear reduced friction. That can mean the meaning coefficient from 0.04 to 0.015. And the next point is expanding the drainage cross-section to increase the flow capacity. So the last point is about the benefit. For first of all, long-term variability, structural change, and maintenance provide lasting solution. The next is about cost efficiency. Initial investment save to maintenance and flood damage costs. And the last point is about environmental consideration. Feature like seal trap and retention zone balance flood mitigation with ecological prevention.
For solution, the step 1 is by using Google Earth Pro, draw a polygon of the catchment area. Step 2, identify the catchment area. The area of the catchment from the drawn polygon is 6.88 hectare. Step 3, select runoff coefficient. The C value for the catchment is 0.95 for commercial and business centers with 20-year ARI design for peak discharge. Step 4, determine overland sheet flow path length. The L for the flow path in the catchment to calculate the time of concentration. So the LO for the catchment is 463 meters. Then for step 5, determine slope of overland surface in percent. The slope of overland surface from the calculation is 0.65%. Step 6, calculate TO by using Horton's and value. Use an equal to 0.015 for paved land surface. From the calculation, we get 13.53 minutes.
Okay, so next step is to calculate area of channel, which is our channel, the trapezoidal shape. So the B width, which is the width is 0.6 meter and the y is the depth is 1 meter. Using the equation of the trapezoidal shape of area, which is A equal by plus zy square equal to 0. Equal to 1.6 meter square. Next is step 9. It is to calculate weighted perimeter of the channel, which is P. So using the weighted perimeter for trapezoidal shape also, which is P equal B plus 2zy, that get 2.6 meter. So next is step 10, which is to calculate hydraulic radius using the area and weighted perimeter that we got from step before, which is one area for 1.6 meter and perimeter weighted perimeter 2.6 meter. So the hydraulic radius using the equation A over P. So we got 0.615 meter. So step 11, which is to determine the friction slope of the channel by dividing the different elevation by the length of channel. So the elevation profile, which is the maximum is 10 meter and the minimum is 7 meter. Using the equation S equal 10 minus 7 over 463, which is the length of channel. So we get 0.0065 meter per meter. So next, calculate travel time in channel, which is the step 12. We use n equals 0.05 and length 463, hydraulic radius 0.615, slope 0.0065. Using the equation below, equation in the slide, we got 2.38 minutes for the travel time. So next is calculate time of concentration by using equation. Using equation below, which is the time of concentration equal to T naught and plus TD. So T naught is 2.38 minutes, TD 13.53 minutes. So we plus between it, we got 16.31 minutes.
Hi, Assalamualaikum. My name is Adam bin Azizan, matrix number 230079. So, for my presentation part, we're going to settle down the rational method. So, basically, our main finding is to find the peak discharge, which is Q. So the formula for Q is ICA over 360. And here are some the information that we have collected, which is the area of catchment, 6.88 hectare, and our runoff coefficient, which is 0.95 based on table 2.5. While for rain intensity, which is I, we need to calculate it before we proceeding to finalize or to find the peak discharge. So a little bit of information for this part is the ARI design is for more than 10 years, and the location of our project is allocated for commercial and building businesses. So for right now, for the rainfall intensity, as we have been using with the informations collected, we have found our rainfall intensity, which is I, is equals to 9.44 millimeters per minute. So after we have found our rainfall intensity, then only we can proceed with calculating the peak discharge, which is Q. So since the formula of Q is ICA over 360, and after we substitute our rainfall intensity and with other informations into the formula, and the final answer for the peak discharge is 1713.88 meter cube per seconds. So for both answers, we need to do conversion instead of minutes and seconds. We need to do it into per hour. So after the conversion of both answers have been made, so for the rainfall intensity, the answer is 566.4 millimeter per hour, while the peak discharge, which is Q, is equals to 6,169,096 meter cube per hour. So that is our final answer for rational method.
Now I can present about the conclusion. The flood mitigation plan for Taman University Parit Raja address flash flood caused by blocked drain, urbanization, flat terrain, heavy rainfall, and adequate drainage system. The plan include routine maintenance, vegetation removal, and structural upgrade like concrete lining and cross-section alignment to improve water flow and drainage capacity. Regular cleaning will prevent blockage, while structure improvement will handle higher stormwater volume, reducing flooding, water stagnation, and damage to property and infrastructure. Despite initial costs, the plan offers long-term benefit, including lower maintenance expense, flood prevention, and improved quality of life. Features like seal trap and retention zone ensure sustainable stormwater management, balancing environment, financial, and technical need.